this lesson, we will become familiar with the product and the quotient rule for radicals. These rules say that if the radical factors that are being combined through multiplication division are real and have the same root, their radicands can be combined through that same operation of multiplication or division. Now, before we get started on more simplifying of radical expressions, become familiar with some perfect squares. What number can you square to get these perfect squares? Since this will help you in simplifying these radical expressions. The same goes for cube roots and also some numbers raised to the fourth power. Here are various examples as a review to simplifying numbers in radical form. Review these before we proceed. And what you should notice on all of these examples is that the root divides evenly into the power on that radicand. So what if the root doesn't divide evenly into the power? How do we go about simplifying this type of radical expression? Well, as for the second problem, 3 goes into 11 3 times. This is the x cubed with 2 remaining, and this is the x squared left under the radical. On this slide, we're multiplying 2 radical factors together with the same root. Therefore, the product rule for radicals says that the radicands can be multiplied together under one radical. Now, we need to make sure the final result is simplified. On the first problem, 5 and 7 have no common factors. Therefore, there'll be no perfect square factors. So we multiply for the square root of 35. On the second, simplify the square root of 25 first, and then multiply. And as for the third, we have the cube root of 8, which we simplify for 2. We now move on to applying the quotient rule for radicals. If the numerator and denominator do not share any common factors, take the square root of the numerator separate from that of the denominator. Here, both happen to be perfect squares, fairly easy to simplify. The numerator and denominator, again, do not share common factors, so we will square root them separately. The numerator requires some simplifying. 2 divides evenly into the 5 on the x to the 5th twice, with 1 remaining. This is the x to the 1st, left under the radical. Again, simplify numerator and denominator by taking the cube root. Let's now move on to more involved problems. We take the square root separately of the 4 factors that make up the radicand. 12 has a perfect square of 4. The square root of this is 2. The 3 is left under the radical. For x cubed, 2 divides into 3 once, with 1 left over. For the y to the 5th, 2 divides into 5 twice, with 1 remaining. And for the z squared, 2 divides evenly into the exponent, nothing remaining. Since the numerator and denominator share common factors, we're going to take the 5th root of the entire fraction so that we can reduce first. After reducing, the denominator is 1, so we can now focus on just simplifying that numerator. The 5th root of 32 is 2. For x to the 7th, 5 divides into 7 once, with 2 remaining. With y squared, the square is smaller than the 5th root, therefore no simplifying can be done. Thank you for listening.